Okay, so this is Daniel Mounier, and I'm going to be doing problem 55, chapter 20. So the problem is a rock from Australia contains 0.438 grams of lead-206 to every gram of uranium-238. Assuming that the rock did not contain any lead-206 at the time of formation, how old is the rock? So we know that the half-life of uranium is 4.5 times 10 to the 9 years. And that this is the half-life equation because radioactive decay follows first-order kinetics. So we can plug this in and make it equal to the amount of the half-life. And from that we can find K. And so K will be used later on in the problem. So then after that, we know that uranium-238 is converted to 0.438 grams of lead-206, and keep in mind that at the beginning we had only uranium-238. So we know that before, originally, that there was a certain amount of uranium that corresponds to 0.432 grams of lead-206. So we do so lead and 206 and uranium-238 have a 1 to 1 mole ratio. So we use their molar masses and the mole ratio to find how much how much the lead-206 corresponds to in grams of uranium-238. And so then we use the value that we found and add it to 1 gram of uranium-238 because we know that the ratio between the two is 0.438 to 1. So now this is the original amount of uranium before any decay happened. And so now that we have the ratio of atoms at the beginning before decay and after decay, we can use this equation, plug in the values. So this one would go here and the initial amount would go down there, and then we plug in K that we found at the beginning of the problem. And so we plug that in here and we solve for T, and we find that the answer is 2.7 times 10 to the 9 years. And so that's how much time it took for the rock to form. Thank you.